All right, so for this lab, we're going to be looking at this cobalt chloride. And this is the cobalt chloride hexahydrate dissolved in ethanol, actually, instead of water. So that forms the cobalt hexahydride compound. I guess this is like a cobalt ion surrounded by 6 water molecules, basically. So it really shouldn't say COCl2 on here. This is our solid cobalt 2 chloride hexahydrate. This is what it looks like in the bottle, right? But then when we dissolve it in ethanol, it kind of dissociates into a cobalt hexahydrate and chloride ions. So I guess there are chloride ions in here. But that's what it looks like when it's dissolved in ethanol. Ethanol is just an alcohol. We didn't want to dissolve it in water for this one because water is part of the chemical formula of the stuff, right? So we didn't want to dissolve it in water for that reason. Anyway, when I put it in my my well here, we can see the color really clearly, and it's like a lavendery color. You actually can't see it super well on camera. Anyway, it's like a kind of like a pale-ish lavender, magenta-ish maybe. But that's going to serve as our control for the rest of the stresses we're going to do at the system, because we have to remember that this is a reversible reaction in equilibrium. This is our cobalt hexahydrate in equilibrium with the product, which is the cobalt tetrachloride. So make sure you're looking at the chemical equation on your paper to make sense of what I'm talking about here, right? This is at equilibrium. I'm gonna add another one here. And then I'm gonna do one of our stresses to it. So the first stress I'm gonna do is adding distilled water. So here I go. I'm gonna add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And hopefully that is coming across on camera. But the one on the right here is the one that I just added water to, and we should be able to tell, again, it's really obvious in person, but we should be able to tell that it is now like a pale pink rather than that magenta color. Maybe if I add more water, it can get pinker. See, now you can tell, it's like definitely more of a pale pink there. So when I added water, that's what happens. That was distilled water. For my next one, I'm going to add in more of my equilibrium solution, and then I'm going to add some, what was the next one? I think it was hydrochloric acid. Here's my hydrochloric acid. This is 12 molar, so this is dangerous stuff. I do not want to get this on my skin. So I'm gonna carefully put that in there. And we can see that color change immediately. So we can see it's turning blue. So record your observation there. That's what happens when we add the HCl. Think about why that's happening. Like adding the HCl, does that increase the reactants? Does it increase the products? Look at your chemical equation again. Think about that HCl and what's in the HCl, and that might help you answer why we're seeing that blue color there. Think about what shift must be occurring there. Why is that happening? Okay, once again, let's do our last one. So that's just the cobalt solution again. Oh no, we have 2 more. We're gonna do the calcium chloride now. Our calcium chloride is a solid. These little white balls. We've seen these before back when we did our ionic versus covalent, identifying or classifying substances, classifying solids. Remember when we tried to dissolve it in water and we checked if it conducted electricity or not. So we can see this one as well. When I added that calcium chloride in there, the calcium chloride itself looks like it's turning blue. All that solution that's touching the calcium chloride is turning blue. What you might ask yourself now, is what do the calcium chloride and the HCl have in common? Think about what ingredients go into making both of these. And then ask yourself why that might turn our solution blue. Great. So now to the last one is silver nitrate. So we have to see what effect silver nitrate has. And to make this one a little bit more interesting, I'm going to add my silver nitrate to the hydrochloric acid one. So this one was the one with hydrochloric acid in it. And that's what turned it blue. I want to see what happens now when I add my silver nitrate. This is somewhat disappointing. Because the colors look so good in person. It's so easy to tell what's happening, but it's harder to tell on video. I don't know why that is. But we can see that it actually turned back to pink. It actually turned back to pink. So the blue is now, there's still a little bit of blue right there, right? But it seems mostly pink now. And it's kind of hard to tell on video, but it's also kind of cloudy now, whereas the other ones are definitely clear. This one's definitely cloudy. I wonder if I can get a better, maybe you can tell. Because that third one from the left, right, that one that I was just talking about, you can't really see light passing through it. The other ones you can. Anyway, the idea is that it's cloudy now. You might think about, why is that cloudy? Did another reaction happen, maybe? And there we go, that's that. So, I hope my commentary was somewhat helpful. If it was hard to see what was going on here. It would have been great if you had done your packet. That way you could have seen this in person. But, oh well. So that is the lab, basically. That was very fast. So now you can fill in the rest of the table. Think about, is it shifting left or right, and what effects that has on reactants and the products. There's one more stress that I'm going to do as for the class as a demo. And that's going to be the temperature ones, so heating it up and cooling it back down. So you're not done recording data yet, but that's it for this video.